All right, today we're going to dive into a really cool piece of engineering that's hiding inside pretty much every device you own that makes sound. It's the unsung hero that takes a tiny, weak electrical signal and gives it the muscle to become the music you love. We are talking about the power amplifier.
I mean, seriously, think about it for a second. How on earth does your smartphone, this tiny little thing, or a portable Bluetooth speaker, manage to fill a room with sound? The actual audio signal inside those devices is incredibly weak. So, what's the secret? How do they get so loud?
You guessed it, the answer is this amazing component. It's like the last stop for the audio signal before it hits your ears, taking that small, delicate signal and giving it the power it needs to actually drive a loudspeaker. This is a story about clever engineering, some really interesting trade-offs, and the constant search for perfect sound. So, let's get right into it. Okay, so first things first, what is a power amplifier's main job? Well, the name kind of gives it away. Its whole purpose is to deliver a large amount of current, or power, to a load, like a speaker. It really is the final, crucial link in the audio chain before that electrical signal becomes actual sound waves hitting your ears. Without it, your favorite song would be nothing more than a whisper. But here's the thing, not all amplifiers are the same, and the way we tell them apart comes down to one surprisingly simple idea.
And that idea is called the conduction angle. Just imagine a sound wave as a full 360-degree circle. The conduction angle just tells us for how much of that circle the amplifier's most important part, the transistor, is actually switched on and doing its job. This one concept, right here, is the key to understanding the entire family of amplifiers.
Which brings us to the first character in our story, the Class A amplifier. You can think of this one as the perfectionist, the audiophile's absolute dream. Its conduction angle is a full 360 degrees. What does that mean? It means the transistor is switched on for the entire sound wave, from beginning to end. It never takes a break. And because it's always on, it creates a nearly perfect amplified mirror image of the original audio signal. The result is pure audio bliss, maximum linearity, and practically zero distortion. Class A amps are famous for their incredible, high-fidelity sound. Since that transistor is always active, there are no weird breaks or stutters in the signal. The sound that comes out is exceptionally clean and faithful to the original recording.
So this brings up a pretty obvious question, right? If Class A gives us the best possible sound, why don't we have one in our smartphones or car stereos? Well, it turns out this perfectionist has a massive, glaring flaw. And there it is, 25%. That is the absolute maximum efficiency of a Class A amplifier. To put that in perspective, for every 4 watts of power it pulls from the wall or the battery, only 1 watt actually becomes sound. The other 3 watts, they're just wasted as pure heat. It's basically a space heater that happens to play music. This makes it totally useless for anything portable, where battery life is everything, and all that heat is a big problem.
So engineers had a huge problem on their hands, and they came up with a really clever solution designed to attack that heat and power waste directly. Enter the Class B amplifier. And here you can see the fundamental trade-off they made. Class B amps crank the efficiency way, way up to a theoretical max of over 78%. That's a massive improvement. But you can see it comes at a cost. The fidelity, the sound quality, takes a noticeable hit. So, how'd they pull off this huge jump in efficiency? Well, they split the workload. Instead of having one transistor do everything, a Class B amp uses 2 of them in what's called a push-pull setup. One transistor handles the top half of the sound wave, and the other one handles the bottom half. Each one is only working for half the time, or 180 degrees, which saves a ton of energy.
But you know how it is in engineering. You fix one problem, and sometimes you create a brand new one. And this new problem was very, very audible. It happens right at that handoff point, where one transistor is supposed to pass the signal to the other. Turns out that handoff was not smooth at all.
See, there's this tiny little moment where the first transistor has shut off, but the second one hasn't quite turned on yet. You get this dead zone right in the middle of the wave. And to our ears, this sounds awful, like a nasty, buzzing distortion. So they fixed the efficiency issue, but in the process, they kind of broke the sound. So, let's recap. We had Class A with its beautiful sound but terrible efficiency. Then we had Class B with great efficiency but that ugly distortion.
The stage was set for an engineering hero to come along and give us the best of both worlds. And that hero was the Class AB amplifier. And the solution they came up with was just so elegant. What they did was they started with that efficient two-transistor design from Class B, but then they added a tiny little bit of voltage to both transistors all the time. It's just enough power to keep them from ever turning completely off. They're always idling, always ready to go, which completely gets rid of that dead zone at the crossover point. Brilliant! And as you can see, Class AB really hits that perfect sweet spot. It gets rid of the nasty crossover distortion from Class B while keeping a really good efficiency of around 50 to 60%. It was the perfect compromise, and it's why Class AB became the absolute workhorse of the audio world for decades. But of course, this story doesn't stop there. As our technology changed, so did our needs, and that led to new, highly specialized kinds of amplifiers. So let's look at two modern designs you'll find everywhere today: Class C and the real game changer, Class D. Now these guys are specialists. Take Class C. Its sound quality is awful, so you would never ever want it for your music. But it's incredibly efficient at amplifying one single radio frequency, which makes it perfect for things like radio transmitters. And then you have the digital champion, Class D. This thing works in a totally different way. It's a switching amp, turning itself on and off thousands of times a second to build the sound wave. This method gets you over 90% efficiency with very little heat, which has been a total game changer for modern electronics. And that 90+% efficiency is a really big deal. Because they run cool and just sip power, Class D amps are the whole reason we can have powerful sound from such small devices. That Bluetooth speaker you love, your home theater soundbar, the audio system in your car, yep, they all rely on Class D to deliver big sound without needing a huge battery or giant heat sinks. So to wrap it all up, it really is about using the right tool for the right job. Class A is for the purists who want that ultimate high-end sound. Class AB is the reliable standard for home stereos. Class C pretty much owns the world of radio. And Class D is what powers all the portable digital sound we enjoy today. So from the warm, power-hungry perfection of Class A to the cool, digital efficiency of Class D, the story of the amplifier is really a story of brilliant engineering. Every single design represents a choice, a trade-off between sound quality, power efficiency, and size. So the next time you turn up the volume, listen just a little bit closer. Because you're not just hearing music, you're hearing the results of 100 years of engineering decisions.